myself. That's why it was delayed. Sorry for that.
Okay.
One minute, please.
Okay.
Can somebody else take over? I will join afterwards. Hello?
Okay, Father. Okay, Father.
Yeah, please, somebody else.
Okay. Gratitude
Could
and
you please
encourage.
take to another person? I will join later.
Okay, Father. Okay. Gratitude and encouragement for your progress. To facilitate this event, I invite Reverend Father Josie Paramtota CMI, Vice Principal, whose scholar T endeavors to continue guide our institution. Father?
Father, now it is okay?
I'm honored to invite Reverend Father Isaac Pidgey CMI, our esteemed principal, to deliver the presidential address and officially inaugurate this FDP. Father, welcome you, Father. Father, did you hear me?
Yeah. Hello?
Yes, Father.
Can you hear me?
Yes, Father. Yes, Father.
Okay. I can't see this. Reverend Dr. Joshi Parandut, our Vice Principal, respected Reverend Father Bichoy, our Administrator, respected faculty members, and Professor Narmada Devi, the Coordinator, and respected faculty members, respected resource persons, and my dear friends. I am very happy to take part in this FDP, Futuristic Technology. We will be dealing with different topics in these coming 6 days, and it will be a very, very apt FDP because technology is revolutionizing all the walks of life and the industry. And education is to be modified and given training for our students in the relevant themes. The 6 days program will be helping all of you to give maximum to our students in our daily life, in our daily learning and teaching. I wish all the very best, and I thank all the resource persons for taking their time and valuable energy for being with us. I am sorry I could not come in time because of the technical glitches. I wish all the very best, and it is because of the meticulous planning and hard work of the Department of Computer Science, Mary Mother College, that we could do this FDP. So I wish all the participants will take it very seriously and enjoyably and learn maximum. I wish all the very best to all the participants. These 6 days will be very useful for you because this is a theme which we are looking forward. And next time, when we ponder over the new technologies, these may not be AI, but it will be quantum technologies. And so we are moving very fast. And so learn and unlearn and relearn what we have and enable our students to be very, very proactive. I wish all success for this FDP, 1 week FDP, and Mary Mother College is happy to see that lot of participants have enrolled online. Thank you very much. Wish you all the very best.
Thank you so much, Father, your kind words. Thank you, Father. Gratitude and encouragement, fuel progress. To felicitate this event, I invite Reverend Father Josie Parantote CMI, Vice Principal, whose quality and endeavors continue to guide our institution. I welcome you, Father.
Dear participants, sorry for the inconvenience. Our Vice Principal could not join the meeting due to technical glitch. Now I invite our beloved Head of the Department, Mrs. S. Narmada Devi, to introduce the Chief Guest.
Pavitra, shall I start now?
Yes, ma'am. Yes, ma'am.
Okay. Good evening to everyone present here. I'm happy to welcome to this 6 days FDP program. It is a privilege to introduce our esteemed chief guest for today's event, Dr. A. Salim Raja, a distinguished academician and researcher with over 17 years of teaching experience across undergraduate and postgraduate levels. His dedication to education and research is evident in his remarkable career and achievements. Dr. Salim Raja holds an impressive array of academic qualification. He earned his PhD in computer science from Bharathidasan University, Tamil Nadu, preceded by an MTech in IT and MPhil in computer science, an MCA, and a BSc in computer science from reputed institutions. These robust academic foundations have shaped his illustrious career and enabled him to excel in both academia and research. In the field of publication, Dr. Salim Raja has made significant contributions to the global academic community. He has authored 16 international journal articles, 32 conference papers, and 10 book chapters, while also serving as the editor for 3 books published by CRC Press. These works span diverse topics, including machine learning, cybersecurity, blockchain, and natural language processing, reflecting his multidisciplinary expertise. Adding to his accolades, Dr. Salim Raja is a respected international journal reviewer for leading publications, including IEEE Open Access Journal, Springer Nature, and Emerald Publishing, among others. His insightful reviews have elevated the quality of research in journals covering areas like cloud computing, pervasive communications, and computational science. Currently, Dr. Salim Raja served as a faculty member in the Information Technology Department at the University of Technology and Applied Science, Oman. Beyond academia, he is a mentor and trainer, guiding students in cutting-edge fields such as IoT, machine learning, big data, and Python. His outstanding professional certifications include Certified Ethical Hacking, Microsoft Certified Azure AI Fundamentals, and Cisco Networking Academy Instructor Certification, among others, showcasing his commitment to staying at the forefront of technological advancement. Ladies and gentlemen, Dr. A. Salim Raja is an embodiment of academic excellence and professional expertise. It is an honor to have him with us today. Please join me in giving a warm welcome to Dr. A. Salim Raja as he shares his wisdom and insights. Thank you. I welcome Dr. Salim Raja.
Thank you, ma'am.
Thank you, ma'am.
Ladies and gentlemen, it's my privilege to introduce our inaugural speaker, Dr. A. Salim Raja, Professor and Research Committee Coordinator at the University of Technology and Applied Science, Sultanate of Oman. Dr. Raja's work exemplifies the fusion of academic rigor and practical applications, which aligns perfectly with the ethos of this FDP. Sir, we are eager to again hear from your insights, sir. Welcome you, sir.
Thank you, ma'am.
Thank.
Shall I start, ma'am? Shall
Yes,
I share
sir.
my PPT? Yeah.
Okay, sir.
Can you see my screen, ma'am?
No, sir.
Yes, sir, it's okay.
Right?
Now it's visible.
Yes. Okay, ma'am. Thanks for the introduction. I really thank Principal Sir and Vice Principal Sir and department heads and members of the department and the faculty members of the college for providing this opportunity to discuss with you. And I hope I will learn more from this session because a lot of new topics in the entire FDP. So it will be useful for both of us. Without further delay, I will move to my topic today. Actually, the initial program was planned by 1 hour, and now it can be 1.5 hours. I don't know exactly how much time I can take, but if anything close to my time limit, please intimate me so that I can rush up to complete my session. Okay? Is it okay?
Yes, sir.
Yes, sir, no problem.
Okay, ma'am. I actually a lot of things to discuss. Initially, I want to know the audience, the participants' levels, maybe teachers or the students. So initially, we planned for the teachers. So I just combined with the theoretical aspect as well as practical aspect. So that will be useful for research scholars as well as the teachers who wants to dive into the AI technologies. So my topic today is the generative AI for languages. Of course, we all know about generative AI. We are living in the age of AI. So every way our works is related to technology. So we are blessed to use new things today. So my topic is organized like this. Initially, I start with the language processing, how system can understand the languages. Then we will move to embeddings, how the technology, the text and voice can be understood by the system, right? So little bit code can also be added. I will explain. If you have doubts, you can ask me at the end of the session. Please note it wherever you have doubt, because I believe that I will go from the scratch so you can easily understand, and even you can from today you can start learning about generative AI and language processing. You can be a good researcher within 6 months period of time. And next is generative AI. What is generative AI and how generative AI can be for languages, and what are the technology behind of it, and key terms that we know in the language processing. Finally, I will come to research challenges and innovations what we have right now. And of course, a lot of research scopes are there. So we will discuss at the end of the session. So AI, as you all know, we are going to discuss the 6 days. We are going to meticulously plan for AI and technology areas. So we need to know what is AI. So as a human, we have a lot of abilities to listen, ability to see, ability to hear, ability to understand, ability to interpret, and even ability to write, walk, sense. Many things we have in our body. The body is built up with a lot of sensor, lot of input devices, lot of processing units. So the same thing when you give it to the system as a computer or a system, so that we called as a AI. AI is a field which includes a broad domain. It is not a single technology, it's a broad domain. So it includes robotics, it includes computer visions, it includes language processing, and a lot of things inside. So the main objective is to make machine us like human to think and act. But still, we are not able to give a machine to think. The ability cannot be achieved, but hopefully we will moving towards achieving the target. So yeah, language processing, simply we can call it as a natural language processing. So the natural language processing is a combination of computer science, algorithms, and language elements, like linguistic elements, right? So it combines both. So language processing, it's a part of AI in the broad domain. So nowadays, the research cannot be a single domain. It can be spread across different domains. I hope you can understand. For example, earlier days, the researchers mainly focus on image processing. Now they move to computer vision. When you come to computer visions, automatically it includes other technologies into the research work. So it is not a single area we can work on. So we should have a broad idea how technologies can be integrated and how we can enhance our research into applications. So AI, NLP is one of the component in AI technology, right? So in the AI main algorithms, as you all already know about it, we have a machine learning. In the machine learning, there is a subset, it's a deep learning. In the deep learning, we have a subset that is we called as a generative AI. Okay, so this is the hierarchy in general. So when you talk about language processing, it come across a lot of years. Okay, so it starts from 1950. The first chatbot, it is Eliza. Now, when you see 2024 and 25, we have a ChatGPT. See how the technology is emerged from Eliza to ChatGPT. In the Eliza, it's a rule-based system. You can see in 1950, it's a rule-based system. So the input and outputs are fixed. When the input question is like this, so you have to answer like this. So this is the way they have created the system. And thereafter, statistical methods can also be added for answering all the questions. Then deep learning technology, machine and deep learning technologies are emerged, and we moving ahead for processing the text in different way. So then we come to in 2017, we have a 2017 onwards, the technology is completely changed into different dimension. So now we have a ChatGPT now, right? So the technology emerging area, when you just go through it, you cannot believe how currently we have these kind of things. Okay. So when you start by learning natural language processing, the basic thing you need to understand why we have to use language processing. See, as a human, we ask some question to someone, they will answer to our question. First, they need to understand our question, then they have to think. The brain will think for the answers. Then we will get the answer from them, right? So same like the system, it will answer to our queries. So NLP, there's a lot of applications. Still many more applications are emerging due to the technology advancement. Past 2 years, I'm just closely watching all the advancements in the area of LLM and generative AI. It's exploding. Okay, so new researchers, they are coming up with different solutions of different problems. So understanding will be very difficult, but yet we can go slowly to reach our goal. So NLP, we can able to build an application for question answering, sentiment analysis, chatbot, text summarizations, language translation, social media analysis, and virtual assistants. So these are all the applications, sample applications here I listed. Apart from this, a lot of other applications too. Even crime analysis we can use, fraud analysis we can use. So a lot of applications we have in the NLP area. So when you talk about NLP, there are two major components. I think I'm audible to everyone, right? Anyone? Am I audible?
Yes, sir. Audible, sir. Audible, sir.
Okay, fine. So the NLP, the main components, two major components of NLP is NLG and NLU. Okay, so the NLU, the system can able to understand human text, human languages. Okay, so that is NLU. So next is NLG. As like human, the system can also generate text. So that is NLG. Okay, so understanding and generation both are combined, or we can have a separate application based on our requirements. So what are the major libraries that we used today to learn NLP? I mean, language processing. So language processing, the basic thing, very basic library is NLTK, Natural Language Toolkit. So we have to use that to learn how to process the text. After that, if you want to go for text classification or higher level application, then we can use for Spicy. And in order to generate embeddings, then we can go for GenSim. And higher level applications like LLM, if you want to design a LLM or if you want to design a ChatGPT like applications, then we can use for TensorFlow, PyTorch. Okay, so I'm just giving an example. So you can have different packages for your own research and application development. These are the basic libraries you must know. TensorFlow, I hope everybody knows about it. TensorFlow from Google and PyTorch from Facebook. So both are good technologies to learn, but when you see the complexity level of writing coding, PyTorch is lightweight, and TensorFlow, you need to do some complex codes, right? So some of the keywords here, if you not understand, please note it. We will discuss at the end, okay? Because I'm not going in detail about every packages, how it can be used. So when you plan to develop applications, or if you want to do some research in language processing, these are the basic steps you need to follow, okay? So I hope you all know about machine learning, how to work with machine learning. If you're not having the basic idea of machine learning, then it's better to have some idea about machine learning so that you can able to understand the technology behind of generative AI, right? So initially you have to collect the data. The data you can get it from the different repositories. You have a GitHub, you have a Google, you have other open repositories, data repositories you have, and even we can collect the data from websites like Facebook comments you can able to read, YouTube comments you can able to gather. For example, if I want to get opinion about Mary Mother College, I can just get the details, comments, feeds from Twitter. I can get the details from Facebook post and the YouTube post and other social media posts. I can able to summarize the opinion about Mary Mother College or any kind of things, any company or product opinions we can able to analyze. So data gathering is very important, and sometimes we need to unearth the data. So that is also very important. It's a challenging task we need to perform at the earlier stage. But if you want to learn the technology, you can directly take the data from major repository. So almost it is refined data, so you can directly use it for your learning purpose. But if you want to do research or if you develop applications, then definitely you need to gather the data directly from the website or from the people. Okay, so then you need to do some pre-processing. There are a lot of methods in natural language processing. NLTK library, as I shown earlier slide. So NLTK is the best library. Spassy is one of the library. We can use it for pre-processing the text. And we have to, sometimes we need to remove the stop words. Sometimes we need to tokenizations. So it's all depends on our applications. What is stop words here? The things like is, was, am, or, these are the common words used in English, so that can be removed if you don't want to process it, right? So then tokenization should be there, stemming and lemmatization. I will go in one by one so that you will understand how it works together. Okay, then we have to convert the text into some kind of numbers. Okay, so systems can able to understand the text in the form of numbers, so that it can able to process. You can apply machine or deep learning methods only on numbers. Okay, so we have to we need to change text into numbers, and we have to choose some model for processing. If you go with the machine learning, you need to choose some models. If you go with the deep learning, you have to choose some models according to your requirements, right? So you have to choose it. And finally, you have to check your model performance, right? So this is the overall work we need to do. As I said already, text pre-processing. The first one is the tokenization. Okay, so tokenization in the sense you have to split the text into number of words. You may ask the question, why should we split number of words? I think why we need to split it, because if you want to make the system to understand your text, you have to split the text into small pieces. Why don't we split it by character? Yes, you can split. Okay, it depends on your need. We can split character by character, or we can fix the size of the words. Okay, 3 character, 4 character. It depends on your need. So you can split it. And as I said, stop word removal. What is stop word removal? Here is an example. So you can see I have a text. NLP has made a significant breakthrough. So in the text, in the sentence, I just remove has made here. Okay, so when I remove it, finally I have 3 words, NLP significant breakthrough. These 3 words, finally I have after stop words removal. Okay, next is we can move to stemming and lemmatization. So what is stemming and what is lemmatization? Both are same process in order to reduce the corpus size. Okay, so what is corpus? Number of words that we have after we remove the stop words, after we completing pre-processing, we have set of words in our back. Okay, so when you create an application or when you processing the text, it is not a single line. It can be a paragraph. It can be a bunch of books, bunch of text. So after you pre-process those text, you have bunches of words. Okay, so in the bunches of words, if it is more, then the complexity of processing will also increase. So in order to reduce the complexity, we have to move the words into root words. Okay, so for example, studied. Okay, these are all 3 different words comes from a single word study. So you can take the word study instead of all the different combination of those words. Okay, so we have to go to the root word. So the processing of moving to the root word is called stemming and lemmatization. There are different methods of doing it. So that's why we call it stemming and lemmatization. Okay. So it gives different results based on your requirements. You can use either stemming or you can use lemmatization. Okay, both are same process. Okay. So you can see the examples here. Stemming, we have here different combination of same word: recover, recovering, recovers, recovered. So all these words from recover, a single word recover. Okay, so when you do stemming, this is the result. When you do lemmatization, same words, we have a recover. So which one you want? Okay, so we can use it. Depends on your application. Okay, so next one, after doing the pre-processing, the next important step is to convert your text into numbers. Convert text into numbers. Okay, so that without numbers, the machine cannot process it. Okay, so how do we convert it? So we have to convert text into numbers, sometime single vector representations, or it can be a dense vector. Okay, so this is we called as a embedding. Okay, so when you convert text into numbers, it can be a single number or it can be a vector. Vector in the sense set of numbers as like array. I hope you can understand a set of numbers. Okay, so that can be an array. Okay, so or you can go for a very lengthy vector. So that's we called as a dense vector. Right. So what are the ways we can do it? So when you do word embeddings, we have different methods. One is the traditional word embedding. Another one is the static word embedding. Next one is the contextualized word embedding. So here we have a GPT. So you can see ChatGPT, right? So the base engine of ChatGPT. So GPT. Right, so these are the different embeddings we have. This is again depends on your applications or research work, we can use it. Okay, so I will go one by one. What is it? Okay, so as I already said, we have a dense vector. Okay, so you can see here for single word good. Okay, so we have a set of values. Okay, you can ask question, how the set of values can be created, who will create it. So everything I will give you answer. Just we go through the next slide, so we will get an answer for all your questions in your mind. Okay, so if you still have doubts, you can ask me at the end. Okay, so the basic traditional word embedding model is the one-hot encoding. So what is one-hot encoding? For every unique words in the input, okay, every unique words in the input, we have to create a separate column in the data. Okay, so every text we have to convert as a number. So how do we convert? So we have to take a complete text, and the text we have to take some unique words. So if the word is present in the particular column, we have to give 1. If the word is not present, the particular column will be 0. So you can see here, I have a text. I will just zoom this so that you will get an idea. So you can see here, I have a text, red, blue, green, blue. So this is my text. So among the 4 words, so 3 words are unique. So I have to create a column for every unique words. Okay, color red, color blue, color green. The first statement, first sentence, I have only red. The remaining values are 0. The second sentence, I have a blue. So I in the corresponding column, it will be 1, and the remaining columns will be 0. So likewise, you have to prepare your data set. Okay, so this is one-hot encoding. So another example also given here, so you can see how we can convert our text into one-hot encoded method. So at the end of the processing, you will see here. I will show you the coding part. So you can see here at the end we have some vector. Okay, so it's look like a matrix, but it's every row, it's every sentence. Okay, so particular sentence, if particular word is there, then it will be 1, and the word is missing, then it will be 0. Okay, so the problem in one-hot encoding, is a lot of zeros. Okay, and we need to we have to adjust our input as per the input we have. Okay, for example, I have first time when I run the program, I have 50 words. Next time when I have 100 words, again I have to build a table. Understand, this is the complexity of one-hot encoding, but yet it is a useful method. Sorry. So the next one is the backup words. Okay, so the backup word, we can also say it's a count vectorizer. So the count vectorizer is again same like one-hot encoding, but it will not create a separate column for each words. Okay, so first it will collect corpus of words. what are the unique words you want to process. So everything will be taken into account. And finally, if the particular sentence having that word, then it will be 1, otherwise it will be 0. Okay, so you can see the examples here. So I have some sentences here. You can see it is a puppy, it is a kitten, it is a cat. So like this, we have some sentences. So among all the sentences, I will collect the words. Okay, unique words. Then I will make it as a column for every words. If the particular word is there in the sentence, I will make it as 1, otherwise it will be 0. Clear? For example, here we have is 2. Okay, in the fourth sentence, you can see because is coming twice, so it is 2. Okay, depends on the count. Depends on the count of the particular word in the sentence, we will take into table. Okay, so then this is we call as a count vectorizer backup words. Okay, how do we do this code? How do we implement it? Okay, so we have a set of sentence. In the sentence, we have to use count vectorizer. As you all know about scikit-learn, I'm not having time to discuss about machine learning packages. One of the package is the scikit-learn package. So we can have a lot of pre-processing methods and machine learning methods in scikit-learn. So if you have time in future, we will discuss more about how machine and deep learnings can be implemented, right? So as of now, I'm just focusing on text processing. So we have to use scikit-learn package. On the top, you can see count vectorizer. When we use count vectorizer, the complete text can be vectorized. Complete text can be vectorized. You can see here. You can see here at the bottom. So we can able to change the complete text into vectors. Okay. So if you give this kind of small illustration to your students as well as your co-researchers, they will get clear idea how to convert the text into numbers. So once they will understand the basics, they can improvise this. Okay, for example, why can't we combine two words into numbers? It's a new idea. So then you can implement it and you can get the results, how it performs. Okay, these are all, the ideas can come up once you get the basics, okay? The next one is the TF-IDF. The previous method, the problem is, it's a very simple to understand, but the problem is we are not focusing on importance of the word, how important those words. Lot of zeros will be there. Entire table is like a sparse matrix. So some problems, we are not focusing on meaning of the word. We are not focusing on importance of the sentence. Just we take account of each and every words, right? So how do we give importance to particular words? Then we come to have another method called a TF-IDF. So in this method, we can able to find what is the significance of a particular word in the sentence or paragraphs. Okay. So TF-IDF, it has two formula. One is the term frequency. Another one is the inverse document frequency. So what is term frequency? Particular word in the particular sentence, how many times it occurs? Okay, when you count it. So that is term frequency. Okay, so you can see here, I just zoom the formula so that you will understand. Okay, so when you have TF, number of times a particular word appears in a document, one sentence. Okay, document in the sense one sentence, and total number of terms in the documents. Okay, so that is TF, right? So the next IDF, when you have IDF, so we have number of documents in the corpus, total number of documents in the corpus. That means number of sentences in your data. Okay. So next is number of documents the particular word occurs. Okay. The first one TF, it focus on single sentence. Next IDF, it focus on the complete list of sentences. When you take in the list of sentence, how many times the particular word occurs. Okay. So that is IDF. When you multiply these two, you can able to have a TF-IDF score. You can see here at the bottom. So we have here some importance. You can see some are 0, some are having values. So that gives importance of the word in the sentence. Okay. So these are the words. Okay. These are the words. So the fourth sentence, this is the third sentence. Okay. What is the importance of and? Okay. So likewise, we can have a significance of each and every words we can able to estimate by using TF-IDF. But still we have some issues. What is the issue? So here we are not focusing on the meaning, understanding of the text. Okay. So we will move to further. So next one is the word embedding, static word embedding. What is static word embedding here? See, the system is creating dense vector for every unique words in the dictionary. Okay, so it is not in the dictionary, it is in the web. Okay, so the system creates every word, it has a unique vector. Okay, so when you have a word, when you want to process a text, every word we have a common vector. Okay, standard vectors. So using that vector, we can able to represent that word in a number format. Okay, in order to understand better, I will give an examples here. So you can see here I have three images. So one is Dhoni, another one is the Cummins, another one is the Australia. Okay, three keywords here. Okay, so we have some attributes, standard attributes for every images. Okay, here I have 5 attributes. So when you calculate value for every attributes, Dhoni is a person, healthy and fit, location, no, Dhoni is not a location. Okay, so has 2 eyes, yes, has government, 0. So likewise, we have set of attributes. In the attributes, we have some values. When you have values for Dhoni, 1, 0, 9, okay, so we can convert as a vector. Okay, similarly for comments, similarly for Australia. So when you have every words, we have a fixed vectors, that is static vector. Okay, so once you have this static vector, you can able to combine, you can able to, excuse me, please mute your mic so that my voice can be clear. Audience, participants, please mute your mic.
Yeah, come on.
Excuse me, participants, please mute your mic. Excuse me. Okay, thank you. I hope my voice is clear now. So every words we have a vector, dense vector. So then what you can do, you can able to compare these two vectors which are close together. I mean, meaning wise, context wise, they are close together. So we can able to perform such kind of analysis. Okay. So when you compare Dhoni and Cummins, both are similar. They have a close contact. Right, so Dhoni and Australia, when you combine, there is a Dhoni is a person, Australia is a location, right? So there is a difference. So we can able to do some like mathematical operation by comparing these two vectors, right? So you can see king minus man plus woman. The answer is queen. Okay, so we can able to compute like this. Right. So what is the problem in the word embedding, static word embedding? So we cannot go for every verse, right? So huge list of words will be there. So out of word vocabulary may be the problem. So suppose you take a word which is not in the system, so what you will do? So that is another question, right? So one of the most common word embedding, static word embedding is, see here in the initial, we have a list of methods. You can see here word to vec. We have a word to vec. So one of the method is word to vec, another one is the glove, another one is the fast text. These are common methods that we have. Okay, so these methods we can use it for our static word embeddings we can use. Okay, so the word to vec and other glove or fast text, we have every language we need to build this. Okay, for Hindi we need to build the model. Okay, I mean build the vectors. All right, similarly Tamil, similarly other languages we have to build a vector. Okay, so without that we cannot do this. So already we have list of languages. The languages we have a standard word embeddings, right? So we can use it. Apart from the list, when you go to glove, when you go to fast text, when you go to word to vec website, so they have listed what are the languages you can able to process. Apart from that, if you want to process some other languages, you have to build by your own, right? So recently I saw some conferences which is organized by VIT and Central University of Tanjore. They have a, excuse me please audience, can you please mute your mic so that I can continue my lecture. Excuse me please. Nagajodi, please mute your mic. Someone else. Ma'am, please. Ma'am, Narmada ma'am, please ask your participants to mute their mics.
Okay, sir, I inform you.
Shall I continue, ma'am?
Yes, sir, you can continue.
Okay, can you see my screen? Yes?
Yes, sir.
Okay. So we have limited languages. We can also build our own vectors. Recently, there was a conference in 2024, VIT, along with Central University of Tanjore. They have conducted a conference for low resource languages like Tamil, Telugu, and other languages. We need some kind of representation in order to process it. Okay, so if you are interested, every year I think they used to conduct. If you can able to participate those conferences, you will get an idea how technologies are emerged, right? So the word embedding, word to vec, we can also say as a transfer learning. Transfer learning in the sense the system is already learned something. We can use it for our own application. That's why we call it as a transfer learning. Okay, so here there are two important technologies we used to have. One is the continuous back of words and skipgram. What is continuous back of words? See here, we have a set of words. From the words, we have to find the next word or the missing words. Then it is a continuous back of words. Or we give a single word, we need to find a set of words. Then it is called like skipgram. Okay, so the first one is we have to give a set of words like filling blanks. So we have a missing word in the sentence. The system should find the missing words, right? So this is the first one, continuous back of words. The second one is we will give a single word. The system should predict the set of words, right? So this is skipgram. Right, so you can use both of these in order to train your models. Okay, so here important thing is the weight. Okay, so here, so you can see here set of weights. It's a deep neural network. It's a deep neural network model. So you can see here some weights are assigned at the final node. Okay, so that will be we called as a parameters. Okay, so that will be for the vector, right? So when you go for skipgram, the first level, some weights are assigned. So this is we called as a vector for the particular word. Okay, so this is parameters as well as the vector for a particular word. right? So this is we called as a continuous backup word and skipgram. In future, if we have a time, so we will discuss more about word embedding, how it works, how to implement it, how to move, how to use this for our research applications. We will see. Now I just show you some of the things, the basic things to you, and we will explore more in future. Okay, so when you have a word to back, I don't have time for fast text and GLOW. The same methods. Okay, the way of processing is different. So in GLOW, we also take words, and fast text we will consider only the character levels, right? So n-gram levels which will be used. So the method of processing is different, but the ultimate is to create a vector, dense vector. It will be created, right? So we can able to perform this kind of operations by using transfer learning. Okay, so this is a simple example how to generate the vector for each words. Here you can see, I will just zoom this so that you will understand. Okay, so you can see here, I have set of words. In the set of words, I'm going to create a vector. I'm going to create a vector. No need to create a deep learning network. Simply, if you use word2vec in Python, so you can able to create a dense vector. What is the size of the vector? It's 100. Every word, the dense size is, every vector size is 100. Window size. What is window size here? So how many words you have to take before you creating a vector for a single word? Okay, so in a sentence, there is a word before, there is a word after. So how do you take those words in order to generate a vector for a single word? Okay, so once you have this word2vec, you can able to create an application. You can see at the end, when you display this for a word, you can see I'm just displaying the word document, the only one word. For document, this is the number representation. You can see here, this is the number representation. Okay, so 100 values will be generated for a single word. Okay, similarly, for words, we can able to create more than 100 values, 350, 250, 512. So we can create as much as we want. Okay, and we can able to compare these two words. You can see here what is the similarity of the word first and one. The similarity value is displayed here. Okay, so we can able to create it. This is we call as a transfer learning. We can use the transfer learning. So I use the Google News vector. I use the Google News vector for simple data analysis, like you have to classify the text, whether it is a spam or ham. Okay, so simple applications we can able to generate by using word2vec model. Okay, next is I will move to the main core part of our today's lecture is the generative AI. Ma'am, how much time remaining? How much time remaining, ma'am?
25 minutes, sir.
Okay, ma'am.
Okay.
As you all know, generative AI is part of artificial intelligence. In the generative AI, we can able to generate text, we can able to generate voice, we can able to generate images, we can able to generate videos. So all sort of things we can able to generate. So here we have two models. One is the descriptive technique and generative technique. In the descriptive technique, we can able to classify some objects. Like suppose you have a model that trained all the animals. When you give a new animal pictures, it can able to classify those things. That is a descriptive techniques. Okay, generative technique in the sense it will learn all the images. You can see the example here. Generative techniques. It will take all the inputs and it will generate a new thing. Okay, so based on your request, it will generate a new thing. So that is a generative models. Right. So traditional models, we have only classification or prediction. Now generative models, it will generate a new thing. Right. So that is we called as a generative AI. Right. So you can see here, we can have a generative AI for language, generative AI for images. Both will be there. So generative AI for languages, it will generate the language text. Images, we can able to create a images, we can able to create a video, you can able to create other applications too, right? So the language model, it can process text as well as voice. Okay, so the image model, when you go for image model, so it can able to process single images, and it can able to create new images, new videos. Okay, so both can be possible. So how the market will be? The generative AI market, as per the predictions, the recent predictions, in 2033, the global market requirements, okay, so 1,764 million USD market is there for generative AI job market. Okay, so you can see the different area: language processing, computer vision, machine learning, and other areas. We have a huge requirements, the experts and scientists needed for performing new set of tasks, right? So we know that generative AI is dominating today, and what is the technology behind of it? Okay, so you can see some I will show you simple videos so that you can understand the power of sorry. You can see. Can you see my screen?
Yes, sir.
Can you tell me whether it is original or artificial?
Yes, sir.
So it's fully generated by AI. It's fully generated by AI. So you can able to generate like real videos, real images. Okay, so that is the power of generative AI now, right? So what is the technology behind of it? That is the transformer. I just quickly go through the transformer because we don't have time to discuss more about transformer. What is transformer? And what are the remaining technologies behind of it, right? So the major technology behind of transformer, generative AI, is the transformer. In the transformer, there are two important components are there. One is the encoding component, another one is the decoding component. Okay, so we will see a little bit more about the generative AI for languages. Okay, so I'm not going to images or videos. I'm just focusing on okay, so I'm just focusing on language part. Okay, so I will just, okay, so the transformer model, who developed it? Okay, so initially in 2017, there was a research paper published. Okay, so these are the authors. You can see these are the authors from Google. Okay, they have published this paper. Attention is all you need. Still, it is available freely. You can check in the website. Repository, archive repository. You can download this paper. Okay, so you can see here how much citations they have. The authors have. Okay, you can see here how much citations they have for a single paper. Okay, so it's huge. You can see, so it changes the entire IT world into new dimension. Okay, so this paper, it talks about attention is all you need. So what it means here, attention, why we need to bother it. Earlier, we used to have deep learning models like we have a RNN, we have a CNN models, we have a LSTM models, but it cannot process lengthy text. Okay, so RNN, it can able to remember some part of the text to generate or to predict the new text. All right. Similarly, LSTM, it has a limitation of memorizing the content, but it is not contextualized. Okay, so that's why we need a new method for processing lengthy text. Okay, why I'm talking about lengthy text? For example, if you listen some story from your grandma or your father or mother, so the story begins with some character introductions. After that, the story is moving, and while moving those stories, they refer the hero, heroine with different names. Okay, so he's doing like that, he's doing like this. So he whenever they refer he, it refers to the name of the person, right? The hero name, right? So the system should remember contextually what it refers. Okay, so when I use he or when I use it, what it means according to the context of the text, right? So we need to process the text as like human brain. The system should also contextually connect with those words. Those connections can be, created by mathematically by this paper, okay, transformer, all right? So when we have transformer today, we have lot of models we have available today. You can see here bunches of models, encoder, decoder models. Okay, Google having set of models, Facebook having set of models. Why those companies having those models? Because they are having huge volumes of data. We are not having data to process. We are not having capability of training the model with the volume of data, but they are having it. So they created models. Some of the models are free to use. Some of the models you have to pay for using those models, right? So generally, language models, language processing models are sequence to sequence models. Generally, we talk about sequence to sequence model. What it means, sequence to sequence? When you give a text, it will produce another set of, different text. Okay. For example, I want to translate Tamil to English. So I give some text. It will translate to some other, languages, English. Okay. So the sequence, it is a sequence, and the output is also a sequence, right? That's why we call it as a sequence to sequence task. So in this transformer, we can able to achieve some kind of contextualization. We can able to connect those words. Okay, so we can able to understand, the system can able to try to understand the meaning of those words. Okay, meaningfully, it will generate the output. So for example, here I gave one statement. You can see here that cat drank the milk because it was hungry. Okay, the second statement, the cat drank the milk because it was sweet. Now, the first sentence, it, okay, it refers to cat. The second sentence, same it refers to the milk. You understand the context, right? So if you want to process the statement in contextual way, still remember, we are not achieving 100%. We achieve somehow to system to understand your text. Okay, so you can see here, while processing the text depends on the context, it will give weightage to the words, how the word is connected to other words. Okay, this is the main contribution of transformer, how the word is associated with other words, so that you can able to contextually link those words, right? So the first sentence, it refers to the cat. Second sentence, it refers to the milk. Okay, so same word, different scores will be generated. You can see here, same word for different sentences, different scores will be given, different numerical value will be given. So based on the weightage, it will connect those words. Clear? So the transformer, generally, when you take it as when you start learning about transformer, it's just like a translation. Okay, one language to another language. Mainly, the transformer was created for language translation, but now it is for complete generation, language generation. Okay. So you can see here, this is the complete architecture of transformer. In future, if we have time, we will implement the complete architecture in Python. Okay, so I will teach you every step how to the transformation happens. Okay, so initially you can see how it is working. So you can have here encoder model. Here you can see decoder model. So in the encoder model, your input will be taken and it will create an embedding. Okay, so what is embedding? Already we discussed. Okay, and positional encoding will also do here. What is positional encoding? Every word's position is important, right? So the word position is also a matter of generating the new text. So we need a positional encoding. And here attention mechanism comes. You can see here attention mechanism is comes. Where you connect it. The contextually how the words are connected. So that can be performed by multi-head attentions. And we also normalize vector. Finally, we apply to feed forward neural network. Okay. Then again, we normalize it. Okay. It's like a layer. This is one layer, like 6 layers or 8 layers we have to perform. Finally, it will give it to the decoder for producing the output. Okay, so the encoder and decoder more or less similar, but slight variations will be there. Okay, so this is the encoder. You can see here encoder. We have 3 encoders into parallel. Okay, similar decoder, we have three decoders in parallel. So in order to produce the output. So when you do here encoder and decoder, some models we have only encoder, some models we have only decoders. Okay, some models they combine encoder and decoders. When you do encoder and decoders, there is a layer normalizations will be there. Okay, for every layer we need a layer normalizations, and we also have residual connections. Here you can see some connections will be there. Right? So why they connected like this? Everything we will discuss only on transformers, how it works. Okay, so if you want to know more about transformers, please go through this website. You can have a step-by-step how it process text. Okay, so everything explained very simple exercises manner, so it will be easy for you to understand. Next is the large language model. I just quickly move. The ChatGPT or any generative models, we have the technology behind is the large language models. Okay, so we have a Gemini today, we have a Llama today, we have a GPT today, and other models also there, right? So what is large language model? The model is a machine or deep learning model. Please remember, model means it's a machine or deep learning model. It's a complete software. So in the software was trained by huge volume of data. Where we get the huge volume of data? So from Wikipedia, from the data available in the websites and other sources, books and other materials, they have collected millions, trillions of text and feed into the system to learn those text. Once it is trained, the complete model is trained, we can use it for our own application. That is we call as a fine-tuning the model for our own applications, right? So what it can do, what it cannot do. Okay, so the large language model like ChatGPT is one of the application of large language model. Please remember, don't confuse with ChatGPT and LLM. LLM is the core, ChatGPT is the application, right? So it can able to imitate like human. It will generate the text, but it cannot innovate. It cannot think. It cannot understand. It cannot reasoning. Okay, so it has some limitations. In future, we may have full-fledged language models. Hope so. Okay, so next is when you have a large language models, we have a data set. The data set will be splitted into tokens, As I already said, what is tokenizations? After that, we have to do some pre-processing. We have to remove something. We have to add something. So pre-processing will be there. After that, we have to train the model with our own machine learning or deep learning models. Then we go for transformer architecture to train the models. Finally, we can able to generate the text. So what are the available LLM models? We have Llama, Falcon, and Stable LLM. So these are all open source. We can use even Gemini having free source available, but you cannot customize it. That's why I'm not including Gemini here. We can use the Gemini API, but we cannot revise the code of Gemini. Okay, but a Llama we can do, right? So these are the open and closed source models. Okay. And so you can see some of the platforms and APIs we are readily available. We can give it to our students and research scholars. They can create their own models and they can build with new applications. Okay, so one of the platform is a Hugging Face. Okay, Hugging Face is the platform. It can provide libraries, it can provide data sets, it can provide API to build your applications. It has set of models. You can also develop and contribute new models to Hugging Face and spaces. You can host your application, real application, by using transformers. Okay, so all the facilities available by Hugging Face. It's a free. Okay, so you can see very simple code to generate ChatGPT like applications. Okay, so you can see here sentiment analysis. Normally when you do sentiment analysis in Java or Python, so you have a list of code to train the model. After training, you have to give input for testing. So these are a lengthy process. So to make it simple, 2 lines, you can see 2 lines of code. You can see, so transformer pipeline. When you use what is the use of this pipeline? What purpose you are going to use? I'm going to use it for sentiment analysis. When you feed your data, it will predict whether it is for positive sentence or negative sentence or neutral sentence. Okay, so you can able to see the results here. You can able to see the results here. So this is the sentence for positive. The score will be here. Okay, so we can simply using transformer API, we can able to build our own applications. Okay, so you can see here it uses Distilbert model. All right. Next one is the Gemini. I'll come to Gemini API. So initially I used POM, I used Bird, I used Gemini. All are it was created with huge abilities to do it, many things. Okay, so Gemini can able to now. Gemini can assist doctors to diagnose the diseases. Okay, to perform certain operations. In order to perform certain operations, they need to perform some kind of pre-assessing. So that can be with Gemini. Okay, nowadays, right? So I will show you at the end of how Google Gemini can work. Okay, so it can process text, it can process video, it can generate the code, it can generate the images, it can generate the audio, everything it can have. So it is a multi-modal. It is not a single model, it is a multi-modal. Okay, so power of Gemini, I will show you at the end. Okay, so how do I use it? How do I use it? Okay, using Gemini, how to create an application? Very simple. So you have to install, you have to use Google Colab. How many of you know about Google Colab? I don't know, but if you can, please use it. You are based, using your Gmail account, you can able to open Google Colab and you can start working on it. It will be saved in your Google Drive. Okay, whatever program you work on the Google Colab, it will be saved on your Drive. Okay, so you can install Generative AI. Okay, so after that, you have to include, these are the libraries, basic libraries. I will come to Streamlit. What is Streamlit? I will show you the output in the next subsequent slides. Okay, here you can see you have to have a Google API key. Okay, so how do I get Google API key? This is the link. Okay, so you have to open this link and you can able to get your, by using your Google account, okay, Gmail account, you can get your API key. Once you have API key, you can use the API key here. Okay, so here I have developed one simple application. It's a question answering. Like ChatGPT, you can create a question answering applications. You can see here, this is the application, Gemini applications. You can see, so you can ask some questions here when you press button. So it will give you answer. No need to give any training. Okay, so ready-made model is available. You can use it. What is the model behind of it? Gemini Pro. So how do I know all the models available in Gemini? So we can have a simple code to display it. What are the models available by Gemini? So we can use it. This is simple. Actually, it has a big list of models available. Okay, so next one, I will show you some of the questions here. If I ask some question, list the universities in Oman. I used 1.5 Gemini. So you can see here, our university is also here. So it will list. I'm not giving any training. It just, I use it, the trained model. Okay. So here I have another question. You can see how to insult someone. Okay. So what is the response you can see? So Gemini, it has some ethics. Okay, so it will not give such kind of things as output. Okay, so when you build a model, you have to be more careful about ethics and culture. Okay, next is, you can see, I just analyzed the photo. What is there in the photo? Okay, so a lot of dishes available. When I ask Gemini 1.5 Flash model, what is inside this? So you can see the output. So we have a rice, we have something. So all the list is given. It will understand your image and it will give you what is inside the image. Okay. So next one, I give some normal vegetarian food. It will also understand. It will give the output. What is there in your plate? Okay. If I ask to write a song, Tamil song by Gemini, so you can see here, it creates a song for it. Okay, so I just come to the end of the part. I will take another 5 minutes to complete the session. Please bear with me. So what are the research challenges we have? First one is the language ambiguity. Okay, so the context and the meaning of the language is complex. When you have different languages, it is completely different context levels. Okay, so two words having same meaning. Okay, so that will also be there. And the computational cost, when you process huge text, it will take huge processing capability, so it consumes your cost. And sometimes the models can be hacked. Okay, so how many of you saw the Endran movie? I don't know. Okay, so in the Endran movie, the robot can be customized based on the training. Okay, if it is with hero, it will act normal. If it is with villain, so it will act a different way. So we can have, our model can also be compromised, right? So next one is the multilingual models. Okay, so now you can see, if you type some comments in the YouTube for a particular video, so you can have Tamil with English, right? So this is multilingual. Okay, so you need to understand your text. The system should understand your languages, right? And sometimes you need to remember, the system should remember the big context levels. Okay, the text length may be more, so the system should remember those things. Okay, sometimes it forgets something. Okay, and code switching, it's also there. Sometimes we have one language to another language. Code switching also be there. This is one of the research challenge. And understanding, as I said already, complete understanding of the text as like human, it is not achieved. So it is yet to move, right? And as you know, plagiarism, one of the big headache for the all the sectors. Now Gemini can create anything that you want. So how do we know whether it is your original or it's created by AI, right? So we have to work on it. So I'm specifically doing some sort of research in these areas. So if you want to have your own research area, you can take it from these things and you start digging on it. Okay, and we have multi-models. So we can understand image, audio, video, everything. So that is again poses challenges. Detecting AI writing. So these are the challenges. What are the advancements we have in the same field? So in order to give, human have some confusion. Sometimes when I ask some question to the students may have confusion because they have different, they read it content from different books, so they have confused to answer it. So this is we called as a hallucination. So system is also having such problems. So it will give wrong output. In order to avoid the wrong output, we have a new model called retrieval augmented generation. So RAG. Okay, so RAG, it is like a database, so it will give some context of text so that the system will not deviate from answering the correct one. It will not deviate much. Okay, so what are the new innovations in it? So we have as I just introduced large language model, now we have new model. It is introduced by December last month, December 20th. Okay, new model was introduced by Facebook, large concept model. Okay, so it is better than LLM. So we need to understand how it works. Okay, so just before I introduce RAG, right? So the new model is there as GOG. Okay, CAG. Okay, so the new models are coming, but yet you have to go from the basics so that you will understand what new technologies are coming, how you can be customize those things. Okay, so I hope the session is good. If you have any queries, you can ask me now. If you have any questions.
Dear participants, the floor is open for an interactive question and gaze session. Participants, please use this opportunity to engage with our expert. Dear participants, it's a Q&A session, so engage with our expert.
Even very fundamental basic question also. Okay. So Nitya Selvaraj, where can use RAG models, right? So it depends on the application. Okay, for example, if I use Gemini, it is already trained, so it has knowledge, right? So for that, we may not need it. But if you customize the Gemini model for your banking application or your college application or your particular domain applications, then we have to use RAG. So when you give RAG also one of the input to your model, then the system, it will take your question and the context and it will generate the answer, right? So it depends on your need. Can we use it for classification? Of course, this is the basic one, right? So any language models can also be used for classification, prediction, and generations.
Hello. Good evening, sir.
Good evening, sir. Please increase your volume, sir. Sahil, sir.
Yeah. Oh, yeah. Okay. Just a minute. Okay. Yeah. Am I audible now?
Yes, sir.
Yeah. So, okay. Just I wanted to have the current session is more practical and at the same time it is more innovative in the explaining about it. Okay.
Okay,
so
sir.
just I wanted to have this can be as per our my understanding, the current RAG models as well as the updated models, whatever you have shared with us, can it be implemented for doctors where while operating, so they have to look at the patient's inner. So rather than going that, can we build a model such a way that so we have text output or voice outputs from the inner environment? Is it be applicable?
Sir, I'm not clear about your question, but anyway, whatever I understand from your question, can we apply this to our real application? Am I right, sir?
Yeah. In medical operations, in surgery.
Of course, sir. We can apply, sir, because we have, for example, if I have some business, my business having some data.
Yeah.
So those data are required for my future operations. So I'm not looking for the general data which is provided by the Google. I want to train my model with my own data along with the additional feature of Google.
Okay.
So in that case, we have to apply RAG, sir.
And one more question, if time permits. So people from tribal areas will not understand our language, right?
Yes.
Yeah. So can we have a model such a way that whatever they wanted to communicate can be generalized or can be converted into a language with these applications?
Yes, sir. Actually, language translation is part of it. So whatever we have today as a demo, it's only on English. It can be Tamil, it can be other languages too. But technologies for implementing the languages we used in India, we have less number of resources. That's why a lot of conferences are conducting to develop new resources for rare languages.
So can we
even IIT Chennai, they have a forum for language resources, low resource language resources. When you just Google it, so you can have a lot of resources by IIT and many institute in India, sir.
Okay, so can we make government any policy, any project like for the applications, what is it, medical emergencies as well as tribal language?
Yes.
Is it possible?
Yes, sir. See, for example, sir, the COVID period, we may not consult doctor directly, so we need assistance from medical people, right? So in that case, now we have a ChatGPT, like chatbots. If you inbuild with your applications, then it can be customized to your own languages, whatever languages the queries comes 24/7, it can support to the patients whatever queries they asked. Some critical queries can be forwarded to the doctors. A normal queries like who are the specialists in your hospital and what time we can get an appointment. So these are all simple questions. Most of the chatbots can be answered, sir, according to your database that you have.
And just one more minute, if permits. Okay, so when a patient is in a critical condition because of an emergency of any accident, so is it possible for us to build a model where by looking at the condition of the patient, it is automatically analyzing what are the things to be needed, means what are the arrangements the hospital can be done?
So that is for IoT, sir. IoT with language models we can combine, sir. So medical conditions we can be observed by temperature of the human body and movement of the human. So everything can be captured through IoT models. Along with IoT models, we can combine language too, sir.
So can we propose this to a government where it can be taken into a reality?
Yes, sir. Already for tribals, already some of the projects there. I saw some of the projects in Indian governments. They have some projects, sir, already.
Okay. So we can apply if there is any possibility from the government.
Of course, sir. If you have new plan of doing this, we can apply, sir.
Yeah. Okay, sir. Thank you, sir. Thank you very much. I took a long time. I'm so sorry for that.
No problem, sir. No problem, sir.
Yeah. Okay. Thank you, sir. Thank you for your information.
Thank you, sir.
But good day.
Any others? Thank you, sir. Thank you, Dr. Raja, for an exceptional session that you set a tone for our FTP. Thank you so much, sir.
Thank you, ma'am. Thank you, everyone, for providing this opportunity to meet you all, even though I'm in different parts. So somehow I can help you, everyone. So you also help me. So some kind of research collaborations we will do definitely, ma'am.
Thank you, sir.
Thank you.
Thank you, sir. I am Father Isaac, the principal.
Thank you, Father, for the opportunity.
Yeah, very enlightening, sir. And today I read in a Hindu newspaper that our chief minister has promised $1 million for rupees for deciphering the scripts of Indus Valley civilization. So you have motivated the participants. I hope they can work on it.
Sure, sir. I hope so, sir.
Thank you very much, sir.
Thank you, sir. Thanks.
Thank you, Father. With enriching this session, we conclude the day one of this FDP. As we gather tomorrow, let's carry forward the energy and enthusiasm ignited today. Have a wonderful evening. Dear participants, attendance link have already sent in the chat box. Please fill it out. Thank you.
Shall I leave, ma'am?